If we have chosen fluid power, in particular pneumatics, we must first generate the energy source in the system, which is compressed air. We do this by compressing ambient air to do work. We're looking at a reciprocating type compressor, which is good for intermittent use and light loads. Rotary or screw type compressors are better suited for steady loads and longer hours of operation. No matter which compressor is used, there is a side effect of heat being generated when the particles are compressed closer together. So, before the air is used, it must be cooled and conditioned by removing the excess water in the air. Let's look at the SMC trainer boards. First, we'll look at the pressure regulator. The pressure regulator is used to set the system pressure. It has a pressure adjustment knob, a pressure regulator gauge. The regulator is connected to a safety shutoff valve, which is then connected to the manifold tree. On this board, there are various directional control valves and 3 cylinders. The cylinders are double acting and single acting. The directional control valves have different activation methods. They operate on the same principle, but they are activated differently. Some by roller cam, such as shown. On the SMC trainer boards, we have 2 double acting cylinders and 1 single acting cylinder. The single acting cylinder spring returns or extends. We can see the different schematical representations of the different types of cylinders available. The directional control valves all operate the same, but are activated differently. They are controlling the flow of air. We're currently looking at a 5-2 double piloted directional control valve. I got all that information from the schematic that's provided on the front of the valve. The 2 flow boxes indicates 2 positions, and the 5 ports indicate the 5. Meaning there are 5 ways air is traveling in and out of this valve. The valves are sealed casings with drilled service ways for air to travel. The service ways are directed by the position of a spool that is shifted back and forth based on the signal method. The previous valve was a 5-2 double piloted operated. This valve is a 5-2 double solenoid operated. The same type of valve, but different activation method. Looking at the top of a 5-2 directional control valve, we can see the stamp B for port B of the directional control valve, and we can see a stamp A for port A of the directional control valve. These are the work-through ports for this 5-2 directional control valve. Looking at the bottom of the valve, we see port EB, port P, and port EA. That's exhaust B, the pressure applied port P, and exhaust A, the 3 ports at the bottom of the 5-2 directional control valve. If we look closely, we could see the spool that's being shifted internally in the valve. There's the spool land and the spool groove. The spool groove allows air to flow, and the spool land blocks the air from flowing. To review, all the directional control valves are sealed casings with a spool being shifted pneumatically, electromagnetically, manually, in some manner of way that's allowing air to flow or not to flow through ports A and B. Pay close attention to the numbering standard. Port 1 or port P is usually the pressure applied port connected to the manifold. Port 2 and 4 or A and B are usually the work-through ports, and ports 3 and 5 are exhaust, or EA and EB. On the board we have some pneumatic limit switches, S2, S3, S4, and S5. They are essentially 3-2 directional control valves, roller cam operated. Switch S1 is also a 3-2 directional control valve, push button operated. We are going to take a further look at cylinders now. The single acting cylinder would only require a signal to the rod end of the cylinder, and it would cause the cylinder to retract. Once the signal is removed, the cylinder will extend because of the spring. We're looking at the cross-sectional view of a double-acting cylinder. We can see the cylinder has a piston with piston seals, and a rod is attached to the piston. When air is introduced into the cap end of the cylinder, it forces the piston to extend as air is exhausted from the rod end of the cylinder. Because of the larger surface area of the piston on the cap end of the cylinder, there is a larger extension force than there is a retraction. In the retraction, the rod is taking up a portion of the surface area, thus the force is reduced. Let's now see if we could control the movement of a double-acting cylinder by controlling which port the air is traveling into and exhausting from. We're going to connect the air first to the rod end of the cylinder to cause the cylinder to retract. As air is forced in to the rod, the air on the cap end of the piston is exhausted through the cap end port. When we move the fitting, the tubing over to the cap end, air is forced into the cap end, forcing the piston to extend, and thus the rod, as air is exhausted out of the rod end port.
Today we've hooked up a time delay circuit. based on the restriction in the flow valve and based on the accumulator size, the tank that's on the back, depends on the time delay. So, as you can tell, as we press the push button, the rod of the cylinder extends. It hits the extend limit, causing air to then flow through the flow control valve, which is then flowing into an accumulator that's in the back of the board. And as the accumulator fills, when it's filled, the air is enough to overcome the spring tension on this valve, causing the cylinder to retract.